The question number 1 and 3 I discussed 2 by 2. Here 3 equations are there, right? X plus y plus z, 3 variables, 3 set of equation. The same way, how you represented in 2 by 2, the same way you are going to write it in terms of 3 by 3 matrix, that's all. Coefficient of x in the first column, coefficient of y in the second column, coefficient of z in the third column. The variable you can arrange it in the column wise, whether it is 2 by 2 or 3 by 3, x, y. If it is 2 by 2, if it is 3 by 3, x, y, z, the constant also the same, it should be in the column. Now we have to see coefficient of x, what it is there in the first one, 1, second, 2, third, A matrix. Next, coefficient of y, 1, 3, A. Next, coefficient of z, 1, 2, 2a. The variable, what are the things they used? X, y, z. That should be in the column x, y, z equal to constant, what it is? 1, 2, 4. The same representation. Collection of x, y, z. The collection of coefficient of x, y, z is represented as capital A. Is represented as capital A. X, y, z, always it represented as capital X. Constant should be represented as capital B. That's all. The same way, what we did it in the 2 by 2, the same thing you are going to apply in 3 by 3 matrix. Here also you want to find determinant A. Determinant A equal to determinant 1, 2, A, 1, 3, A, 1, 2, 2A, right? The same. If it is 2 by 2, it is easy, product of main diagonal minus product of sub-diagonal, but here it is a 3 by 3 matrix. First entry is positive, second entry is negative, third is positive. Like that you have to move in a cyclic, right? Now 1 into, if you are selecting this element, that row and column should be deleted, then it becomes a 2 by 2 determinant. What you will get? 3 1 into 3 2 A 2A. For your convenient, I am writing, I am representing in determinant, or straight away we can do if you are confident. Minus 1 into, if you are selecting this, that particular column and row should be deleted. The rest of the entry is 2 A 2A plus 1 into determinant. You are selecting the third entry, so the first row and third column should be deleted. The rest of the thing is 2, 3, A. Now 1 into product of main diagonal 6A minus 2A minus 1 into, again product of main diagonal minus sub diagonal 4A minus 2A plus again product of main diagonal minus product of sub diagonal 2A minus 3A, right? Now what it is? 6A minus 2A, 4A. 4A into 1, 4A minus 4A minus 2A, 2A. So 1 into 2A, 2A. Here plus 1 into 2A minus 3A, that is minus A. Addition, so that is positive and negative, so you get it as negative minus A, which is equal to 4A minus 3A equal to A. Here you cannot conclude whether the system is consistent or not. So how to conclude whether the system is consistent or inconsistent? We have to go for adjoint of A into B. Suppose, first condition, if you assume A is not equal to 0, assume A not equal to 0, then in that case what is your thing? Determinant A is not equal to 0. Then you can say the system is consistent. The system is consistent. It has unique solution. It has unique solution. Because you are arriving the variable as A, we cannot conclude whether it is equal to 0 or not. Suppose two cases will arise, right? So if A not equal to 0, your assumption is not equal to 0, determinant A not equal to 0, the system is consistent, it has unique solution. The next is, if A equal to 0, next assumption is A equal to 0. If A equal to 0 means what is the determinant? Then determinant A equal to 0. If once you arrive determinant A equal to 0 means you want to evaluate adjoint of A. You want to evaluate adjoint of A. Adjoint of A, evaluate adjoint of A into B. You want to check adjoint of A into B. What is our matrix A? You see 1, 1, 1, 2, 3, 2, A, 2A. 1, 1, 1, 2, 3, 2, A, 2A. Adjoint of A. Before, you should write the matrix A first. Matrix A equal to 1, 1, 1, 1, 1, 2, 2, 3, 2. Two, 3, 2, then third row is what? A, 2A. A, 2A. This is your matrix A. For that you want to find adjoint of A. If it is 3 by 3, adjoint of A means you want to find cofactor. The simple way we taught it, isn't it? So, for that purpose what you have to do? 3. That you should write it in the right side. Center element 3, below and then above. Next, move towards right. 2, 2A, 1. 2, 2A, 1. Then move towards left. 2A, 1. 2A1. The last one, what you want to fill? You have to use the first element, the same 3. Here also 2. Here also 2. The last column should be filled by the first column, right? 3 in A, 1, 3. The last column should be filled by the first column entry. Now you should see 6A, right? Cofactor. Cofactor of A equal to 6A minus 2A. 6A minus 2A. Next, 2A minus 4A. 2A minus 4A. Next, 2A minus 3A. 2A 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 minus 3a. Next, you should draw the arrow like this. The previous exercise we discussed a lot, right? A minus 2a. The same way. 2a minus a minus a minus a, then 2 minus 3, 2 minus 2, here it becomes 3 minus 2, 3 minus 2, now which is equal to 4a minus 2a minus a, positive negative, do the subtraction and put the greater number symbol several times I said, right? 2a minus a, here it becomes 0 minus 1, 0, 1. This is cofactor. Adjoint means what you want to write? Transpose of cofactor. Transpose of cofactor means what? You want to convert the row into column, right? Transpose, that is adjoint of A equal to 4a minus 2a minus a. The first row you are writing in terms of column. Second row minus a 0. Third row you are going to write it as a third column. This is your adjoint of A. What I wrote here, adjoint of A? Adjoint of A equal to 4a minus a minus 1 minus 2a 0 minus a 0 1. Adjoint of A, how to find? You want to find the cofactor. For that, middle element, below and above, again the same entry that I wrote it in the right side. The same way, middle element, below, above, the same. Below, above and same. Next, middle element, below, above, the same, right? The last column should be filled by the first column entry. Then the normal, main diagonal minus subdiagonal, that logic you applied and find a cofactor. Adjoint means what? The transpose of cofactor. Transpose of cofactor is nothing but the row into column. What I wrote it in the first row 4a minus 1. 4a adjoint of A into B equal to 4a minus a minus 1. 4a minus a minus 1. Next, minus 2a 0. Minus 2a 0. Minus 2a 0. Sorry. Minus a 0 1. Minus a 0 1 into B. What is our B? 1 2 4. What is our B? 1 2, 4, right? Adjoint of A into B. The first row, first column. 4A minus 2A minus 4. Second row, first column. Minus 2A, 2A minus 2A plus 2A plus 0. Next, minus A plus 0 plus 4. Adjoint of A into B, which is equal to 2A minus 4 2A minus 4. Here it is cancel. So what you will get? 0 minus A plus 4. Definitely it is not equal to 0. If it is not equal to 0, what is your conclusion? The system is inconsistent, right? You can say the system is inconsistent. But you have to check. Suppose if your A equal to 0 means the third equation is what? Third equation is AX plus AY plus 2AZ equal to 4. It is not possible when you substitute A equal to 0. If you consider A equal to 0 means the third equation is not possible. So finally, what is your conclusion? The system is consistent. The system is consistent. Because if determinant A, that is A not equal to 0, you can get determinant A not equal to 0. The system is consistent. It has a unique solution. If you are arising the thing A equal to 0, then you get it as determinant A equal to 0. If determinant A equal to 0, we want to move to the adjoint of A into B. Adjoint of A into B is not equal to 0. If it is not equal to 0 means your conclusion is it is inconsistent. That is right. When you substitute A equal to 0 in the third equation, it won't be satisfied. That's why the final conclusion is the system is consistent.